Hi all, this video lecture we are going to discuss about the sequence diagram. So let me tell you what is a sequence diagram. So this will specify the number of interaction diagrams. So the UML will specify the number of interaction diagrams to model the dynamic aspects of the system. So when I say dynamic aspects, what are all the messages flowing among the objects, the flow of control among the objects, and the sequence of events. So all this will be represented in the diagrammatic representation. That is what we say it as interaction diagrams. Okay. So when it comes to the UML diagrams, in the interaction diagram, we have sequence diagram and communication diagram. And apart from this, we have state diagram and activity and swim lane diagram. So all these diagrams will tell you the behavior of the system. We say this as a behavioral modeling. Okay. So in this video lecture, we will see how to draw a sequence diagram. So this is going to show you the flow of messages, events, and actions between the objects. So that is what we say it as sequence diagram. So it shows concurrent process and the activations. Also, it shows the time sequences that are not easily depicted in the other UML diagrams. Okay. So here, typically this is used during analysis and design to document and understand the logical flow of your system. So this is the representation. So here you will be having, these are all the actors or objects. Okay, this is the interaction between the objects. Say for example, you have student, you have seminar, and you have course. So first, first action is the student enrolls for a seminar. So once he enrolls, internally, it is checking for the eligibility. Is the student eligible for that particular course? And then the history is generated. Okay. So first, the student is enrolling for a seminar. So internally, so the student is validated, the profile is validated whether he is eligible for that particular seminar. And then the history about the seminar is sent to the student. So this is how the interaction exists between the objects. So this is how it is diagrammatically represented. Okay. So you can see here. So all the lines should be horizontal to indicate instantaneous actions. Additionally, if activity A happens before activity B, then activity A must be above the activity A. So this is the time increasing order. In this order only you have to put first, this is the first one, followed by the second one, then the third, then fourth. So it should be in a time increasing order. That is how the activity should be represented. And when it comes to object, so you can see here, student is a class and a student is the object. This is specific instance of an object. So a student is a object of the class student. So here you cannot see any object. This we say it as generic. Seminar is the class. You can have some generic object for the class seminar. Similarly, course is a class. You can have generic object of the class type course. Okay, so these two are generic objects, whereas a student is a specific object. Okay, so two main things we have discussed. One is generic object and other one is specific object. Also, when you are representing the interactions, it should be time increasing. Okay, so this is this tab, this rectangular box, we say it as lifeline. Okay, so here this is the lifeline of that particular set of instruction. First, the student is enrolling. Here the student is checking for the eligibility and then the result is returned to the student. This part we say it as execution and this one we say it as lifeline. Then the seminar history is sent. Then eligibility status is sent. Finally, the enrollment status is done. Okay, so this is the lifeline for that particular action. So this we say it as method call. Is student eligible? This is a method. So this is a method call, and the information or the output is returned. This we say it as a written enrollment statement. We are checking for the eligibility and we are returning the status. So this is one process, method call and return. This is how you represent a method call and return status. Okay, this is a sample sequence diagram for an ATM system. So here the actor withdraw the money. So once you're choosing the option to withdraw the money, this will check for the balance in the banking system. And then if there is a you have sufficient balance, then you go for dispensing the money through the money dispenser, and then it is printed. Print receipt is enabled. Then the printer prints the receipt, and finally the ATM controller ejects the card and ends the transaction. This is how a withdrawal system is represented using a sequence diagram. So there are three different types of links you can see. One is synchronous message, then you have asynchronous message, and you have a written message. These are the three notations which can be used for synchronous, asynchronous, and written message. Thank you.